Now let's learn how to differentiate the inverse trig functions. I'm going to do in detail the arctangent and then write down the results for the arccosine and the arcsine. You can look at more detail in my lecture notes. So to determine the derivative of the inverse arctangent, we start with that the tangent of the arctangent of x equals x. So we're going to use implicit differentiation here to figure out what is the derivative of the arctangent. So we differentiate both sides of this expression. We know that the derivative of the tangent is equal to the secant squared, but it's the secant squared is just 1 over the cosine squared. So let's leave the cosine here. So the derivative of the outside is 1 over the cosine squared of the arctangent of x times the derivative of the inside, which is what we're looking for, d dx of the arctangent of x times the derivative of the right-hand side equals 1. So now we can solve this implicit equation for the derivative of the arctangent by just multiplying through by cosine squared arctangent of x. So we have the result that the derivative with respect to x of the arctangent of x is equal to the cosine squared of the arctangent of x. Okay, so that's the cosine of the arctangent of x, the whole thing squared. So we've seen expressions like this before. You remember the trick to do that. We write a right triangle. We choose this angle here to be the argument. So that's the arctangent of x, right? So we want the tangent of the arctangent of x to be equal to x. The tangent is the opposite over adjacent. So this side becomes x, this side becomes 1. And then we can figure out the hypotenuse is just the square root of 1 plus x squared. Okay? So then the cosine of the arctangent is the adjacent over the hypotenuse. So the cosine of the arctangent is 1 over the square root of 1 plus x squared. And then we have to square it. So we get 1 over 1 plus x squared. So what we've derived is that the derivative with respect to x of the arctangent of x is equal to 1 divided by 1 plus x squared. And this is a very useful formula because it's valid for all real values of x. The arctangent is defined for all real values of x, and it has a derivative for all real values of x. So this turns out to be used quite frequently. If we wanted to find then the derivative of the arccosine or the arcsine, we start with a analogous expression. So we would start with, for cosine, we would start with cosine of the arccosine of x equals x, and then do implicit differentiation. For sine, we would start with sine of the arcsine of x equals x, and do implicit differentiation. We would work out the, say, the cosine of the arcsine or the sine of the arccosine using right triangles. And the results we would get would be that the derivative with respect to x of the arccosine of x would be minus 1 over root 1 minus x squared. And the derivative with respect to x of the arcsine of x would be plus 1 over root 1 minus x squared. For the case of these two functions, we see that x cannot equal to 1 or negative 1. So for that, x will need to be less than 1 and greater than negative 1. Okay, arctangent's very nice because it's valid for all real numbers x. I don't remember these two second ones, but the derivative of the arctangent comes up a lot, so it's worthwhile to remember that. So let me summarize. To determine the derivatives of the inverse trigonometric functions, we use implicit differentiation. So here to find the derivative of the arctangent, we start with the tangent of the arctangent of x equals x. We differentiate, and then we resolve what is the meaning of the cosine of the arctangent of x using a right triangle. So the result to remember here is that the derivative of the arctangent of x is equal to 1 over 1 plus x squared. The other two you can look up. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.